Alright, well hello everyone. Haven't done a Gravi Stil video in a while, and I just wanted to show you guys basically how to clean these things. We have a lot of customers that have asked this, like what do you do and what do you look for? And this is kind of a treat because this is the very first. We have been running this system for 4 years now, give or take, almost every day. Sits right on this stove, actually on the back burner, but we moved it to the front burner just to show you guys some stuff. But first thing we're going to do is I'm actually going to have to set this camera down for a moment, and we're going to show you how bad this water is in the bottom. That this system has been running now without a cleaning for about 2 weeks. We run it about 2 weeks before we clean it. But mainly, I mean, this is all settled. You'll see once we open this thing up what it looks like in there. But I kind of wanted to show you on the TDS meter what the water in the boiling chamber looks like after 2 weeks. 753 total dissolved solids. So I would consider that very hard water. But anyway, we'll show you guys some production here in a little bit, and we'll also show you how to clean this thing. But this actual distiller is so old we don't even have a label on it. You know, like our production models have labels. It has the old valves. We use the new stainless steel valves now. But the reason we got rid of these is that they leak bad. You can actually see ours even leaks, and can't even keep the thing from dripping. But this thing is dirty. So we'll show you cleaning methods, and especially since we've been running this so long, and I'll be right back. By the way, I just wanted to mention, do not drain your Gravi Stil when it's hot. This unit is dead cold, 70 degrees right now in here. But to drain this thing, all I do is put in a little container on both ends. We'll drain the top first usually, you know, so I don't have a second hand at the moment. But just use the valve, drain it into a container, and then drain the bottom into a container, and then the system's light enough that you'll be able to move it. So we'll go ahead and move it over to the sink, and I'll start taking it apart. Okay, so we're basically almost empty. Always has a little bit in the bottom. So we'll go ahead and take that off and lift off the feeder tube. You'll get a little bit of water drip out of there sometimes, and then just hold it over and empty it out. And then I'll set that aside until we get that clean later. So, by the way, this is like I said, one of the older versions that actually has it's actually 201 stainless, which they're all now 304, but we just never upgraded our own unit. So we'll open this thing up, that off, and inside here's our float, which will need to be cleaned a little bit. But you can see all of the stuff just floating around in there. So actually not as bad as I had anticipated on the distiller side, but still 750 total dissolved solids isn't great. So we'll go ahead and do this now, and I'll come right back and we'll start scrubbing. Yeah, I'll typically use I use like a little scrubby pad, you know, just one of those Brillo pad type things, and then I just use soft scrub. Seems to work fairly well, and scrubs it up really nice and easy. Yeah, these are about as simple to clean as a regular pot and pan, so you don't need any special tools or chemicals or anything to clean one of our distillers, as opposed to a coil operated distiller that a lot of people use. Now onto the float. Now you'll notice there's a little gasket right here. Just got to be careful not to lose that down the sink. And then also, this rod can get grimy. This is where the water feed comes down, so we'll want to scrub that up so it's nice and shiny and smooth again. Alright, well, we got the lower boiling chamber all cleaned up and back together. Go ahead and Pop that down with the float inside. Sorry for the poor quality filming. I thought someone was going to be here to help me do this, but there's the float inside. So we'll start cleaning the rest, the collection plate and the top pot. Well, that was quick. There's really not a whole lot of reasons to clean or scrub the collection plate since it only has the distilled water in it. It took me all of like 5 seconds to wash it out, but I just do it when I pull everything else apart. Alright, we'll remove the feeder tube from the bottom of the condensing pot, the small pot, and proceed to wash just like before. Alright, condenser pot is clean and ready to go. Last thing we have to do is to clean the feeder tube. Now this can, here I'll pull this back, this can get a little bit of grime and stuff built inside where the float that's on top of there will not slide up and down properly. Now that takes months of not cleaning, by the way, but we have done it just to see how long we can run. So I just grab one of these little bamboo skewers and run that down and kind of scrub it up and down if you don't want to use any chemicals. When I'm lazy, which sometimes happens, iron out. I just put a little bit in a flat bowl or something and lay that in there. That eats away all the lime and everything, and I rinse it off and wash it and put it back. So there's two methods for you to do it. You can use toilet bowl cleaner and stuff like that as well if you wanted to, but if you clean it often, you can just use a skewer or a pipe cleaner or anything like that to kind of scrub down inside that tube. So really not a big deal. The only time we use the chemicals is when we ran it for 2 months straight, just to see how long it would run without cleaning. Alright, got the feeder tube put back in with the elevator bolts and everything, and we're ready to slide it right back down on top of the distiller. And then we'll go ahead and rotate it around and get it ready to fill. Source water that I'm using is just right out of the tap, and 532 parts per million total dissolved solids, and a pH level of 7.1 according to my meter. 7.11, so probably settle out right around 7.05, give or take. Alright, we got the system back together and filled up the top pot. It's still filling the boiling chamber through the valve in the bottom. You can kind of see it down in there. But so this will settle off. I've got water in the bottom, probably close to an inch, I would imagine, give or take, since I know how long it takes to fill these. But I can go ahead and start the burner. I'll go ahead and turn that on. Now, a couple things we're going to talk about when we're operating this thing. I output all my water into a glass container, and it has no valve or anything because those little plastic valves sometimes will melt. The output temperature of the water is going to be 150 degrees, give or take, when this thing's running for a long time. Second thing, some people have asked, well, how long do the silicone hoses last? This is the original hose I put on this thing 4 years ago. It has gotten stiffer for some reason. I don't know what that is, but the hose is perfectly usable. Another thing is that this is a pot, a very large pot of very hot water once it gets going. So put it on the back burner. Be careful that no one can knock this thing over, and do not try to move it when the system is hot. Another question people have asked, well, do I need to put ice in here or in the top pot or anything? No, you do not. The way the system works is using evaporation to cool the top pot. There are ways you can speed it up. You can drain the water out of the top pot and replace it with cooler water. But believe it or not, the highest output of the system, this top pot runs about 140 degrees. Now, this is an open distiller. This is not a closed distiller like electric distillers that cost you an arm and a leg to run. This means that out of this hose will come water and steam. When this thing is operating, and if you're using a very, very dirty water source, perhaps a lake or a stream or something like that, the volatile organic chemicals that are in the water are going to boil at a lower temperature. Well, they're going to come out of this hose in vapor, and all the water is actually going to condense and go into your pot, or most of the water. It's going to be water vapor as well. So when you're running this inside of a home, which we are currently, show you our stove and how it's set up here. When it's running on a stove, it's going to get humid in the house. So you have to understand that the production of the system and the top pot temperature will increase the more humid it is. I will sometimes open the window right over here. You can see my wood pile. Open the window over here just to kind of cool it off in here a little bit so that we don't steam up the house. Running this system outdoors, it runs the fastest. Now we are working for 2019 for a modified version of our Gravi Stil that will use some form of electric for cooling only and still use gas. But that's a little ways off. We're in testing on it. Testing results look hopeful at the moment. But it'll actually run on a solar panel or actually just use a backup battery for like a cell phone. So, but anyway, at this moment, and any of our systems, I should mention, any of our systems will be able to convert over to that. It'll use the same pots, everything that we have currently. So you'll be able to add that as an add-on if you want to increase production by using some form of electric cooling source. So anyway, we'll get this thing going here. We're just turned it on and the burner is running. You can see it's already starting to condense just water vapor out of the air on the pot. And we'll show you how this thing produces. Alright, just got back inside. I had it running while I was gathering some wood for the fire. But we have water producing, and I wanted to show you guys a couple things that people ask. There will be some condensation on the boiling plate, just because that's colder and it will condense a little bit until the system heats up. But you can see we've actually made, I don't know, maybe 3 or 4 cups of water. This container here is about 1.25 gallons, give or take. And but you can see the water just flowing out. And you can also see the water vapors. Now, that's normal. As the system warms up, you'll get a little bit more water vapor, but then you can control that with the flame by turning the flame down a little bit. I have this thing running on pretty much high at the moment, just when it first starts. And you can also see the water level has dropped about 1/4 inch or so. But anyway, yeah, we'll check back with you here in a little bit and let it run. Alright, I want to show you guys the power of evaporative cooling. We're just using water as a cooling source. Just like in your car, that's the reason cars use a liquid like water, which is 50-50 water, but is that it can absorb a lot of heat, and also through the evaporation process, which you can kind of see the vapors coming off and wicking against the stainless steel, cooling is happening. So this system can basically run indefinitely just like this, as long as you don't overdrive it too much and pump too much heat. But about 10,000-15,000 BTUs is all you need, which is the size of a normal burner on a stove, like this one here. But anyway, so that's what's cooling the system. You can see water has dropped, and I'll show you a little thing that's happening here. You can see some of the water vapor coming out of the system as the water keeps on coming out of the hose here. Wait till a big drip happens here. And now we're going to go ahead and fill and top off our system. Add some more water to it, and the system will contract for just a moment, and then you'll start seeing water start flowing all over again. Just interesting as you add cold water to the condenser, and then all of a sudden it starts flowing. So, but that's exactly how the system works. As long as you keep on adding water to the top pot, maybe every 20 minutes to half an hour, the system will run indefinitely. And that's how we originally ran the system and filled two 55-gallon drums with distilled water. Just continually fill the top pot, adding cool water to this pot. This pot's the boiling pot. The water comes up, condenses between those two plates in the condenser, and runs out the hose. Alright, we're back for something kind of fun here. I ran some distilled water in here a little bit ago into a small cup, just so I can show you what's going on here. You remember our source water was 750 parts per million total dissolved solids, using our little meter here. Our tap water was 500, and distilled water is, well, look at that, 0. So, 0 parts per million of total dissolved solids. Here, let's see if we can get a pH really quick. I know this thing takes a while to adjust, and in warm water, may not get the best results here, but we'll give it a moment here to, it takes a while for these things to start reading. It'll drop, 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 drop. And so slightly basic water. So anyway, just thought you guys would find that interesting. We'll keep this thing running. You can see the water that we made here. So we're probably at, since this thing's at 1.25 gallons, we're probably about a half gallon, give or take, 8 cups. And it's been, well, I didn't really look at the watch when I first turned it on, but we're about probably just at an hour right now. Alright, final check-in here. You can kind of see the water vapors coming off of the condensing pot, which I wanted to show you guys. The cooling method for this system. And water still coming out. Just once again, just keep on filling this pot. I keep it about a ½ inch below just because I'm lazy and I get don't want to come check it all the time, but about every half hour I come in here and dump some water in it. And here we are, we're about, I don't know, what is that? It's about pretty close to 1 gallon. It's been just at 2 hours, maybe a little over 2 hours right now we've been running it. But I did turn the burner down as well. We're sitting at medium low. If you get too much water vapor pouring out, here I'll turn it up just so you can see. I'll turn it up and you'll see the faucet come out here. But it produces water faster when you boil the water harder, but it also produces a lot more water vapor, which then in turn raises the dew point in our house, fogs our windows, and also causes the cooling pot to cool slower, because as we increase the dew point, the water does not evaporate as quickly. So I just turn it down. We'll turn the burner down here a little bit, so we're roughly medium-ish, medium-high-ish, and then water will start coming out here again. After I just blew all the water out of the system, it'll take a moment to catch up. And then we'll start producing water again. So start producing water again. And there it is. Okay, so anyway, wanted to sign off. If you guys have any questions, obviously let us know. And that's how the system works. And obviously I made the video earlier of the cleaning process for this. And then I just want to mention once again that the valves have been replaced. You can see there's a small little drip right there, and that's the reason we replaced those, is that if we can't seal these valves up every time, we don't want to sell a unit that has a leaky valve. So the new valves are much better, and they allow you to seal this up completely. But anyway, let us know if you have any questions. Obviously place a comment in the bottom of the video if you do, or you can email us directly through our website at SHTFandGO. So stuffhitsthefandgo.com. Thanks.